everyone. So today I'm going to share the first application for Form 5 Chapter 2 Differentiation. There is gradient of tangent and normal. Alright, so you're gonna see for a curve here. Alright, for a curve here, we have the equation for tangent and normal. Alright, tangent is a line that touch the point. This is my point, right? This is my point. So tangent is the line that will touch the point at the curve. Alright, so this is tangent. And normal is a line cuts the point and it's perpendicular to the line of tangent. Right, so this is the tangent and normal that we need to know. Alright, so how to find tangent, or what is the thing that we do on differentiation to find our tangent? Alright, so for this first application, gradient of tangent, our gradient is found by using dy dx. Alright, so our dy dx is actually finding our gradient. For gradient of what? Gradient of a straight line. Gradient of this straight line. Because we know in straight line we have y equal to mx plus c, right? So this m is get by dy dx. Alright, so this is the first thing that we need to know in differentiation. Alright, so in this chapter, if they want you to find the tangent, they will use three types of words, like gradient of the curve, gradient function, and gradient of tangent. Alright, so normally we know to make an equation, you will use y equal to mx plus c, but this is more towards mathematics. So for Addmath, you will use this formula. Okay, y minus y1 equal to m bracket x minus x1. So this is the equation that I will use in every equation that I need to build during Addmath. Alright, in mathematics you will use y equal to mx plus c, but for Addmath you're going to use this formula. And just now I have said normal is a line that is perpendicular to the tangent, and we learned in Form 4 Chapter 7 Coordinate Geometry. So we know when two lines is perpendicular to each other, their gradient times together is equal to -1. So when we do differentiation, we will get the tangent, we will get the gradient of the tangent line. So if you want to get the gradient of the normal, we can use this m tangent times m normal equal to -1, because they are perpendicular. Alright, and we need to know that in building one equation, we need to have two conditions. That is our m and at least one coordinate x and y. Alright, so let's start with first example to know more about this concept. Alright, the question is find the equation of tangent and normal of the following curve at given point. Alright, first thing is equation of tangent. I'll make it bigger, sorry. Equation of tangent. And then the second one is equation of normal. Alright, so equation of tangent, that means y equal to mx plus c, right? So like I said, I will need a m and a c. Alright, I will need an m first. Okay, I will need an m. So the m is the gradient. So in this gradient, I can get from differentiation. So I will do this differentiation. Okay, you must really familiar with how to do differentiation, that is times and minus. I have introduced it in my previous video, so please check out if you still don't know how to differentiate. you're gonna times it, and you're gonna divide. You're gonna minus, sorry. So we will get 2 times 3, you get 6, and then my x power 2, 2 minus 1, I will get 1, so I will get x. And for second one, this one x, I have 1 power 1, so 1 times negative 1, I will get negative 1. And this x, because I will minus 1, so I will get 0. So x power 0 is equal to 1, so I will get negative 1. And for this negative 4, if I differentiate, I will get 0, so nothing. So my dy dx is 6x minus 1. Okay, this is my dy dx. This is my dy dx. And then I need to sub my x. I need to sub my x with the x of the coordinate, because you want to know the equation of tangent at that point. For example, I have this is my negative, my negative 1, and then this is my tangent. So I want to know the tangent at this point, so definitely I need to sub this x by my x coordinate of this. Alright, so this x I will need to sub my x coordinate. So I will get 6, negative 1, minus 1, and I will get negative 7. This is my dy dx. Alright, and then for equation of tangent, I get my gradient is equal to negative 7, and I get 1 point, negative 1, 0. So I will use this formula. I'm gonna write here. Y minus y1 equal to mx minus x1. Alright, so this is my x1. I'm gonna use red lah. This is my x1. This is my y1, and this is my m. Alright, so we sub into this formula. So y minus y1 is my 0, equal to m is my 7, my x1 is negative 1. Alright, so y equal to negative 7, x plus 1, because negative become positive. And then I open the bracket, negative 7 times x, negative 7x, negative 7 times 1, negative 7. So this is my equation of tangent. Alright, the next one, I need to find my equation of normal. Alright, for equation of normal, of course we need to have gradient and a point also. And a point we have in our question, negative 1, 0, but we don't have the gradient, right? But we know gradient of tangent times gradient of normal is equal to negative 1. So above, we know that our gradient of tangent is negative 7. So that means negative 7 times my negative times my gradient of normal, I'll get negative 1. So my gradient for normal is 1/7. Alright. Okay, so I will use back this formula. Y minus y1 equal to m bracket x minus x1. So y minus y1 equal to m x minus x1. So I'll get y equal to 1/7 x plus 1. So I'll get y equal to 1/7 x plus 1/7. Alright, so this is my equation of tangent and equation of normal. So actually in this first application it's quite easy, because you just need to know how to differentiate and do the sub or the x coordinate like that. Okay, alright. So the second one, we need to find the equation of tangent also. Equation of tangent. Alright, we need to have a m and a coordinate. So m we can get by using dy dx, but we don't have a point, right? Because in this question, we know they just give us an x coordinate, so we need to find the y. So we're gonna sub our x equal to 1 into this, so to get my y. So I'm gonna sub it. So my x is 1, so 1 square minus 4 and square, so I will get 9. So now I know my point is 1, 9, so I can do my differentiation to get my gradient. Alright, so this one is called composite function. Use the composite function rule. There is we times and minus also, but we times here in front and we minus here. After that we have a bracket. Alright, so we do here. We do here. So dy dx equal to, I times here, so I'll get 2 x squared minus 4. Then 2 minus 1, I'll get 1, but I didn't write the 1. And after that, I need to differentiate this one, the thing in the bracket. So for this one, alright, for this one, I need to times and minus. So I will get 2x. So actually I will get 4x x squared minus 4. Alright, and then this is my dy dx. So I need to sub back my x equal to 1. So I will sub my 1 times 1 squared minus 4, and I will get negative 15. So I use this formula to get my equation. So there is y minus 9 equal to negative 15 x minus 1. So I will get 1 minus 9 equal to negative 15x plus 15. Okay, negative 15 times x, get negative 15x. Negative 15 times negative 1, I will get positive 15. So my answer will be y equal to negative 15x plus 6. Alright. Sorry, I will get negative 12 here. Sorry. Here I will get negative 12. Here I will get negative 12. Alright, negative 12x plus 12. So I will get negative 12x plus 21. Sorry, here I pressed wrongly the calculator. Alright, so this is my equation of tangent. Then I need to find my equation for normal. So I will use m tangent times m normal equal to negative 1. So here I get my m tangent is negative 12. So it's like this, negative 12 times gradient of normal, I'll get negative 1. So my gradient of normal, I will get 1 over 12. Alright, because negative 1 divided by negative 12. And then I will press, and then I will write y minus 9 equal to 1 over 12 x minus 1, is it? So I will get y equal to 1 over 12x, and then 1 over 12 times negative 1 plus 9, that is 107 over 12. Alright, this is my equation of normal. Alright, if you need this note, you can screenshot. Alright, okay, so we go for the next question. you need to find the equation of tangent and equation of normal. So alright, for this one, which one is tangent? Tangent is this. Tangent is this line that touch the point, okay? And the normal is the line that is perpendicular to the tangent. Right, so this one need to differentiate. Actually, the hard thing in this is how to differentiate, because sometimes they will come out something that is really hard to differentiate. So your answer will be wrong if you differentiate wrongly. Alright, so this one, our y equal to 2 minus 3 per x equal to 2 minus 3x power negative 1. I need to, because I can't differentiate when it's underground, I need to put it to the ground floor. Okay, so I will times and minus also. I'm gonna times and minus, because these two, if I differentiate, I'll get 0, so nothing. So it's actually nothing. We don't need to differentiate any number. Alright, so here negative 1 times negative 3, I will get 3, and then negative 1 minus 1, I will get negative 2. Okay, I'll get negative 2, x power negative 2. This is my dy dx. So my dy dx will be 3 over x power 2. Because I don't want to write the x power outside, so I will use the indices. We learn, okay, I write here 1 over an equal to a minus n. Indices, okay, form 4 chapter 4 is quite important topic. Alright, so I will get this, and like usual, I have one point here, a point A, 3, 1. So I'll find my equation of tangent. Equation of tangent. Alright, so my gradient, that's my m, is equal to 3 over my x is 3. 3 over 3 squared, so I will get 1 over 3. So I will use that formula. I'm gonna write here. Right here. Y minus y1 equal to mx minus x1. This is not provided in your formula list. Alright, so y minus 1 equal to 1 over 3 x minus 3. So y equal to 1 over 3x, and 1 over 3 times negative 3 get 1. Sorry, 1 over 3 times negative 3 get negative 1, and then negative 1 plus 1, I will get 0. So I'll just get y equal to 1 over 3x. Alright, and the second one, equation of normal. Equation of normal. We use that formula, m tangent times n normal equal to negative 1. Alright, so I will get 1 over 3 times gradient of normal, get negative 1. So my gradient of normal is actually negative 3. Alright, so I will use that formula also. 1 minus y minus 1 is equal to negative 3 x minus 3. Is it okay? So I will get y equal to negative 3x, and then negative 3 times negative 3 plus 1, I will get 10. So my equation of normal is negative 3x plus 10. Alright, and we go to the second question. Question 2. A curve have a gradient k squared minus 5x. Gradient here, this is my gradient, where k is a constant. The tangent to the curve at the point 2, 4 is parallel to the line y minus 2s equal to 7. Find the value of k. Alright, so first we need to understand the question first. So she said a curve have a gradient k squared minus 5x. So this one is my dy dx. Alright, so they told us the dy dx, so I'm gonna write actually the dy dx at 2, 4 is parallel to y minus 2x equal to 7. Alright, that means, okay, so first parallel. What is parallel? Parallel means gradient same. Gradient is same. So can we find the gradient for this one? So this y minus 2x equal to 7. So actually y is equal to 2x plus 7. So we write in y equal to mx plus c form. Alright, so this is my gradient, so this is my gradient. So I know when at point 2, 4, my gradient is 2 because it's parallel. Alright, so this is the information that I get. So I will just sub it. This is my dy dx. I already get my dy dx. My dy dx is kx squared minus 5x. So we sub this 2 into this x, and we know our dy dx is 2. That means k2 squared minus 5 2 equal to 2. This is my okay, alright, this, do you understand? Because my gradient at 2, 4 is 2. So my gradient I get from dy dx. So that means my dy dx is 2 also. So I will sub my x coordinate into this. So I will get 4k minus 10 equal to 2. So 4k equal to 12, so k equal to 3. Alright, and in exam, please write below because I want to save the space for the next question. So I'll write above. So this is the answer. K equal to 3. Alright. And the third question, find the x coordinate of the points on the curve points. Alright, more than one. X coordinates. Okay, on the curve y equal to x squared plus 1 over x, at which tangent is perpendicular to the line 3y equal to 2 minus 4x. Alright, so we need to know that we need to get the dy dx first. And they told us the tangent that means dy dx is perpendicular. Perpendicular means m1, m2 is -1, perpendicular to the line for this. So you write in the y equal to mx plus c form because you want to get the m. So here we have 3y equal to 2 minus 4x. So because I need to write in y equal to mx plus c form, that means 3y equal to -4x plus 2. So my y is equal to -3x plus 2 over 3. So this is my gradient. And they told us tangent is perpendicular. That means I need to, this one, -4 over 3, I times my gradient of tangent, I'll get -1. So my gradient of tangent is equal to 3 over 4. So what is gradient of tangent is actually dy dx. So I know my dy dx is equal to 3 over 4. Alright, so we go back to the question. We have this curve. We have this y equal to x squared plus 1 over x. So you need to do the differentiation first. You can separate this to this. So you get x squared over x plus 1 over x. So I will get this bottom. I will get x plus 1 over x. This is just my y. And I need to do differentiation. Before I do, I'll write it x plus 1, x plus 1, x minus 1. Alright, so I will do times and divide this my power 1 times and minus, I will get 1, and this I times that negative 1 minus 1, I will get x power negative 2, I will get 1 minus 1 or x power 2, x squared. So that means this my dy dx. So here I get my dy dx, and above this my dy dx, and I know that my dy dx is 3 over 4. So I know my 1 over x squared is equal to 3 over 4. That means negative 1 over x squared is equal to negative 1 over 4. So 1 over x squared is equal to 1 over 4. And because this is 1 also, so I just ignore it. So I will get x squared equal to 4. So my x will equal to plus minus square root of 4. So my x will be 2 and negative 2. So the question 1, x coordinates. So I get 2 and negative 2, but I need to write it back. The x coordinates are 2 and negative 2. Alright, so this is the question 3. Alright, so we go to the question 4. Okay, the question 1 is to, I think I use blue pen, it's more okay, is it? You can differentiate between the question and the answer. Okay, so I will use blue pen, I think. So find the equation of a tangent. See here, equation of tangent to the curve y equal to x squared, x minus 3 at point this. Alright, so it's really simple for us, because we know if you want to find equation of tangent, we need to have an m, that is my gradient, and a point. And here we already have the point here, so you want our gradient. Our gradient is we will get from differentiation. So y equal to x squared, x bracket x minus 3. Alright, you have two choices, that you can use product rule, but it's way more spend your time. Alright, so and another way is you just expand it. Okay, so x squared times x, we will get x cubed. X squared times negative 3, we get negative 3x squared. So I can get my dy dx. My dy dx is equal to L times m minus, so 3x squared times m minus negative 6x. Alright, I'll get this one. Alright, and then okay, and then I want to find the equation of tangent, so I sub my x equal to 3. So my dy dx will be 3 squared minus 6, 3. So I will get my answer, that is 9. Alright, and then we will use the formula y minus y1 equal to mx minus x1. Alright, I repeat many times so that you can remember it. Okay, so I know now my m is my 9, my coordinate is 3, 0. So y minus 0 is equal to my m is 9, x minus x1 is 3. So I will get y equal to 9x minus 27. Alright, actually I think this topic is quite okay one. Okay, for question B, if the tangent to the curve at point A in question A, tangent to the curve of, I use a bigger one, tangent to the curve at point A in A. Okay, so let me ask, tangent to the curve at point A in A is what? Tangent to the curve, that means dy dx at point A. We already sub at point A, So it's 9. Alright. And at point B are parallel. Find the coordinate of point B. Alright, what that means? That means at point B, my dy dx is equal to 9 also. And this is the most important information. If you can't get it, then you can't do the question. Alright, and then they want us to find the coordinate of point B. Alright, that means my dy dx is 9 when at B. Alright, so my dy dx is 3x squared minus 6x. So they told us 3x squared minus 6x equal to 9. So 3x squared minus 6x minus 9 equal to 0. So we all can divide by 3. So I will get x squared minus 2x minus 3 equal to 0. And bracket, press calculator, I will get x 3 minus time. I will get x equal to -1 and x equal to 3. Alright, so which one I will pick? I will pick -1 or I will pick 3. Alright, I will pick -1. Why? Because I look here at my point A. I use another color. My point A is 3, and they share same dy dx, right? So I will get my x is actually -1. So I already get my x coordinate, so I need to get my full coordinate. So I need to sub back, use the equation here, the equation they give us at first. Y equal to x squared x minus 3. So y equal to -1 squared, -1 minus 3. I will get -4. Alright, so I will get, we write back, b is -1, -4. Alright, this is the fourth question, question 4. Alright, we look at question 5. The normal to the curve y equal to 4x at point A 4, 1 intersect the curve again at point B. Wow, the question is a bit like confusing, right? So if you look at the first, normal to the curve y equal to 4x at point A first, intersect the curve again at point B. Alright, we stop here and you see. Alright, and you need to really know this concept. When we do dy dx, we will just get the tangent. If you want to get normal, we need to do m tangent times m normal equal to -1. So we do the different, so what's the step? So first one, we differentiate first, we get the gradient for tangent, and then we sub this 4, and then we use the m tangent times n normal equal to -1, and then we get that gradient, and then we do y minus y1 equal to m x minus x1, then we will only get the equation of normal. Alright, and intersect means sub y equal to 1, sub, that means y equal to y. I will show you later, okay? That means this point B is the intersection point lah. Okay, so the step 1 is actually we need to do the differentiation. Alright, so I write it upwards because I don't want it to be underground. So I will do differentiation times and minus -1 times 4, -4, x minus 1 minus 1 minus 2. So I write it back at the down. So this is my dy dx. This is my gradient for tangent. Alright, and then I sub my x is 4 here. I sub here, and I'll get -1 over 4. Alright, this is my gradient for tangent, and then I want to find my gradient of normal. So I will get 4. Alright, so this is my gradient for normal. Okay, and then we use that formula, y equal to y1, y minus y1 equal to m times x minus x1. So you will get y minus this point, y minus 1, this point, equal to 4, x minus 4. You will get y equal to 4x 4 minus 15. This is my equation of normal. And they say this equation of normal intersect the curve. So curve I get y equal to 4 of x. My equation of normal is y equal to 4x minus 15. So when intersect, we know y equal to y. That means this is my equation 1. This is my equation 2. So I'm gonna sub 1 into 2. Alright, that means 4x minus 15 equal to 4 of x. Alright, and then we times outwards. Okay, so I will get 4x squared minus 15 equal to 4. Alright, so 4x squared minus 15x, sorry, minus 15x equal to 4. So 4x squared minus 15x minus 4 equal to 0. So this is quadratic, so again you can press calculator. So I will get 4x here, x1, 4, negative, positive. So I will get negative 1 over 4x equal to 4. Alright, so we see here, we'll choose x equal to negative 1 over 4 or negative 4. Oh, sorry, negative 1 over 4 or 4. So we see here, at this, we already have 1 is 4. So we will choose negative 1 over 4. Alright. I think I need to show here. Let's say this is my curve. This is my fourth one. And this is my fourth one. My fourth one. Alright, so let's say this is my tangent. This is my tangent. So this is my normal. Alright. Because we know because this is reciprocal graph. The reciprocal graph is like this. So I have this. Okay, I need to draw really long this one. So this is my point A here, and another point is here. This is my point B. Alright, so this is actually what it looks like. Okay, so and I can see here, so I will guess my x is negative 1 over 4. Okay, alright, we get negative 1 over 4. So I sub back in this equation, or in this equation any of it. I will sub my x equal to negative 1 over 4. So I think I sub at this, y equal to y equal to 4, negative 1 over 4 equal to negative 16. So my point B will be 0 pula, negative 1 over 4, negative 16. Alright, so this is my question A. And question B, find the area of triangle. Okay, area for triangle we learned in form 4 chapter 7, also coordinate geometry. To find the area of triangle, you have that 1 over 2, and then x, and then y, this time, and then minus blah 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 blah, like this one. Okay, and we need to write the formula in anti-clockwise form. Alright, so the first thing, we need to find the area, you need to draw first. This is my O, that is 0 0, and my A like here, 4 4 1 4 1, and my B like here, -1 or 4. Okay, should be downward a bit, like here, -1 or 4 16. So I connect it, so triangle. So I anti-clockwise, I start with this, like this, like this, and like this back. So this actually revision, okay, revision for your form 4 chapter 7 to get how to find the area. So 1 over 2, so first 0 0, -1 over 4, -16, 4 1, and the last we need to write back the first thing, the first 0 0. So after that I will get, okay, you need to write out the jalan kira, okay, times, that means 0 times -16 plus -1 over 4 times 1 plus 4 times 0. Alright, I forget to do that modulus here. And then I minus this one. Can I change color? Okay, and then minus this, minus this, minus this. Okay, so I will get 0 times -1 over 4 times -16 times 4 plus 1 times 0. So I will get 1 over 2 -1 over 4 minus -64. So I will get 255 over 8. Is it? -1 over 4 minus -4 times 1 over 2. Yes, 255 over 8. Okay, so that's all for our first application of differentiation, that is gradient of tangent and normal. If you feel this is helpful to you, please like, share, and subscribe my YouTube channel and also my TikTok video. Bye. So you see at the next video, that is the next application for turning point. Okay, so please check in. Okay, bye.